Okay, in the equation number 6, you determine whether the equation defined by y has a function of the x. The easy way is put in the calculator. I put in the calculator. This is a sequence of the key that you have to press. I press graph, I saw the curve, and you apply the vertical line test. In this case, you see clear, it crossing only one point, then it is a function. Okay, number 7 is find the domain of the function. So you see we have a fraction. You take the expression and the denominator, and this expression must be different to 0. This is the restriction. And you solve this inequality. In this case, factorization is x is common factor, x squared minus 64 must be different to 0. This is the difference of a square. Again, factorization. X 8 plus or minus must be different to 0. Now x must be different to 0, x must be different to 8, and x must be different negative 8. Okay, let me write the answer. The answer in formal way is domain of h. Domain of h of x is equal all real numbers such that satisfy this condition must be different to 0, comma, must be different to 8, comma, and must be different to negative 8. That's it. Okay, number 8 is the same. It's find the domain of the function f of x. In this case, we have a fraction and we have radical. Therefore, the restriction is x minus 3 must be positive. No 0 and no negative. Only positive. And you solving is x greater than 3. Then the domain of f of x is all real numbers such that satisfy this condition must be greater than 3. What is the answer? Okay, if f of x is equal to this expression x squared minus 3 over x plus 5, I need to evaluate x plus 1. So this is just replace. This is x plus 1 squared minus 3, x plus 1 plus 5. In the denominator we have x plus 6, and the top we have x squared plus 2x plus 1 minus 3. Therefore, f and x plus 1 is equal x squared plus 2x minus 2 over x plus 6. Correct? That's the answer. Okay, question 10 is very easy. We have two functions f and g, and you need to find the division. So the division f over g of x is f in the numerator and g in the denominator. This is expression. Now, in order to find its domain, we take the expression and the denominator must be different to 0. Also for x must be 1 divided by 6. X must be different to 1 over 6. The domain is all real number such that x's must be different 1 over 6. And this is the answer. To answer the expression and its domain. Both answer. Okay, number 11 is determine algebraically whether the function is even, odd, or neither. Remember the systematic way. You replace x for negative x. If when you replace, you obtain exactly the same as even. When you replace, you take completely opposite sign as odd. Otherwise, neither. Then let's do it. F and negative x. is equal minus negative x cubic over 9 negative x squared plus 7. Negative x cubed is negative x, another negative is positive, over 9x squared plus 7. When you compare this expression and the original, you see that we have opposite sign. Don't confuse it, guys. Remember, when the fraction is negative, when you have a fraction, for example 3 over 4, so when you have a negative here, it's the same that you have a negative in the bottom, or it's the same that you have a negative in the front, no? So this negative, if you want, you put in the front, and here, and you see it's negative. So this negative, this entire expression, and this is positive. So it's opposite sign, completely opposite. Therefore, the conclusion is it is odd function. Okay. Okay, 12 is similar. It's determined algebraically whether the function is even odd or neither. Remember, replace x for negative x. This is minus 4 times negative x over absolute value negative x. In this case we have double negative positive, this is 4x over the absolute value negative x is positive x. When you compare this expression and this expression, completely opposite sign, the conclusion again is odd function. Okay. Okay. 13 is do the graph of this piecewise function. Let's do it in the graph of each piece separately. This is a line intersecting one and a slow one, 1, 1. It's obvious. Okay, this corresponds with this line. This is a line x plus 1. This is a constant function, 3. This is 1, this is 2, this is 3. 3 is a horizontal line. This is 3. Okay. The partition or the boundary is in 1. 1 is super important point. Dotted line here. And this is 1 here. 1. Okay, now before 1, the mathematical law is this. So we have empty circle, and we travel for this line, and this continues to infinity. And after we jump to the constant function, that is from 1. And the red is the graph of the piecewise function. Okay?